All right, class. Now see, in the last class we had started, so basic questions that were needed we had completed from the starting portion, but some of the topics couldn't be completed. So inertia is what? Inertia is the inability of the body to change its state of rest. It can be state of rest, it can be state of motion, it can be state of direction. So until and unless an external force is applied, right, until and unless an external force is applied, that property will remain as it is. Like if the state of rest is there, so it will continue to be in the state of rest until and unless the external force is applied. All right, so this is also known as Newton's first law. Body will maintain its inertia unless an external force is applied on the body, and only that external force can change the inertia of the body. Now, there are three types of inertia as I've mentioned: inertia of rest, motion, and inertia of direction. Next quantity, which we also have discussed, is momentum, mass into velocity. Direction we have to keep in mind as it's a vector quantity. And a wall falling and reflecting on the wall questions also we have seen. Newton's second law of motion says that external force, it basically just tells that is equal to rate of change of momentum. From this only, you can use this formula directly. F is equal to change in momentum by change in time. And you can use this as F is equal to ma as well. This is Newton's second law where mass is constant. So force is equal to ma. F is equal to ma is from here also. So again, force is a vector quantity. SI unit is Newton. And 1 Newton is equal to 10 to the power 5 dyne. Now Newton's second law of motion. All right, Newton's second law of motion, third law of motion. Third law of motion says that, so to every action, there is equal and opposite reaction. And action and reaction, they are instantaneous. They cancel each other. This is what you have to remember here. Impulse also you should remember. Questions on impulse are also there in your NEET exam. This is basically force for a very short duration of time. That is known as impulse. So average force multiplied by the time of contact. This is the impulse. Rest of the questions, I think these part we have done. And we have to just revise friction also. Frictional force was also there. Now, so for these frame of reference, you should know the place of observation, inertial frame and non-inertial frame. So when the frame is at rest or uniform motion, we say this is inertial frame. And here only we use Newton's law. If it's a non-inertial frame, your frame will also be accelerating. Like if we are observing a pendulum, which is present within the truck. If the truck is at rest, that will be inertial frame. You will use Newton's law. But if suppose the truck is also moving and pendulum is also moving inside the truck, so now that is inertial frame, non-inertial frame. Now you will not directly use Newton's law. You will have to apply pseudo force, a force that will be present there. Now, frictional force is what? It basically opposes the motion. It's a dissipative force. So static force, limiting force, and kinetic force. So in static friction, it's the self-adjusting friction that acts on the body at rest. So actual motion has not started, it is self-adjusting. Before it's like, if you look at this figure, initially, let's say the force, applied force is 1 Newton, frictional force is also 1 Newton. So body won't move. If I increase the applied force, if I'm pushing this, I'll increase my force, let's say 2 Newton. Frictional force is also 2 Newton. I'll notice that within this force, the body is not moving. So all these forces are static frictional forces. It's self-adjusting. Whatever is the force you will apply, it will adjust itself. But it has a certain value. That maximum value of the static friction is known as limiting value. After this, suppose I have increased the force to 10 Newton. I am noticing that frictional is still 2 Newton. So my force is heavier. I am able to push the object. Now the frictional force that is remaining is kinetic friction. So these are the three types of friction you should remember. And this is the graph. So it's like static friction is adjusting. As I am increasing, the frictional force is increasing. As external force increases, frictional force increases, and so on, until a maximum value is obtained. So that maximum value is the limiting, known as the limiting friction. Maximum value of static friction is known as limiting friction. And once this is clarified, the object begins its motion. And as soon as motion is there, so this is kinetic friction. What are the causes of friction? Irregularities between the objects, basically. Interlocking forces between the objects. Both the objects get interlocked between each other. It's like one edge is this, we are not able to see these irregularities because these are on microscopic level. And suppose this is a box that is kept on a table, so table also will be having such irregularity. However smooth surface you take, there is going to be certain irregularities at the microscopic level which you'll see. So what happens is that this interlocking between these, when they are rubbed against each other. So in the, suppose this body is motion occurring in this direction, frictional force occurs in opposite direction. This is the basic cause of friction. That's why if you apply oil on your hand, now when you will rub your hands will move smoother because oiling has decreased the irregularities present on your skin. So what has happened? After oil you have applied, you are smoothly able to move your palm against each other. Similarly also, if there is a very smooth shiny surface, a glass is kept, and you're trying to move on it, you will slip because the irregularities between your foot and the glass, they won't be getting interlocked with each other. So intermolecular force between two surfaces is the cause of friction. Now, laws of limiting friction. This basically says that whatever is the frictional force, it is directly proportional to normal reaction. Class, do not remember it. F is equal to mu mg. This is not the formula. Formula is only mu n. That is coefficient of friction is mu, n is normal reaction, F is the frictional force. Do not remember. Many people remember this formula and apply it in every question. This is not the formula. When your normal reaction will be equal to mg, then only you will use this. If your normal reaction is suppose equal to mg cos theta, so will you use mg still? No. If let's say your normal reaction is not equal to mg in some question, suppose if say this is the body like this, so normal reaction is perpendicular to the body, but gravitational force will always act downward. So is the normal reaction equal to mg? No. So you cannot use mu mg. So many students remember it like this. Always remember it is mu n. And this is independent of area of cross section. Even if you take a larger object, even if you take a smaller object, it depends upon irregularities. So this is how do we write it? F is equal to mu n. Now mu L will become coefficient of limiting friction, right? Mu S will be coefficient of static friction. Mu K will be coefficient of kinetic friction. I've told you basic formula for friction will remain the same. For frictional force will be directly proportional to reaction in any ways. You do not have frictional force equal to weight. Do not confuse it with that. In most of the questions, normal reaction balances the gravitational force. But if you have questions like this, is the normal reaction balancing the gravitational force? No. There will be some pseudo force which will be balancing the gravitational force. Frictional force, it can happen. Frictional force is directly equal to mg, whatever is it. But your formula is that your normal reaction and frictional force, they are directly proportional to each other. And however you are increasing the roughness, the frictional force will get increased. Number of irregularities increasing, roughness of the surface increasing, more is the grasping power, more is the friction present. Lesser you apply smooth oils and just lubricants on it, that reduces the friction. So application-based questions are usually not asked from friction. Directly in laws of motion, you have questions from this only. Likewise, these questions are asked. An angle of friction, remember, normal reaction is there, friction is there. So there's a resultant between normal reaction and frictional force. Let's say this is the resultant. If you apply normal parallelogram law, this is the normal reaction. And let's say this is the frictional force acting. So if you apply parallelogram law, these are representing the two adjacent sides of parallelogram. So how do we have the resultant? It is given by the diagonal of the parallelogram, right? So this angle that the normal makes with the resultant of normal and frictional force, resultant and normal, this angle, this is known as angle of friction. So it is the angle which resultant of normal and frictional force makes with the norm. This is what is your angle of friction, which is equal to tan theta directly. Angle of repose is when if you have kept the body on an inclination plane, inclined plane, if you have kept the object. So as the big body just begins to move, whatever is the angle now, that is known as angle of repose. When the body just begins to move. Angle of friction will remain always. It will be this angle. This will be angle of friction. Angle of repose won't be this. So this is F is equal to directly tan theta, mu is equal to tan theta. So angle of repose sometimes becomes equal to angle of friction mathematically, but they do not have their physically, they do not have the same meanings, but mathematically the formula is same. So wherever angle is given, mu tan theta, you can easily apply it and use it. Circular motion, I'll be doing it tomorrow only. So I think we should practice some questions from this. Whichever portions we'll be including it from, equilibrium will also be included in here only. Let me write down the question, same thing. You will be just noting it down. First, you will try to answer by yourself. Let me know whatever answer you're getting it. Then I'll discuss it. And all of you try to answer. I just received one score of your mock test. Last was, I think, yesterday. Before that, mock test before that. So did you all receive the score for that?
Yes, ma'am.
Okay, okay. So what all were the scores? Just text me in the chat column.
Only for physics or the entire one?
Send me the entire one. Only two students have written Hanifa and Saifullah. Okay, Alan. Alan's scores, I think, has been maintained, no? Other students also, just let me know your score. So Maimuna, Alan, Hanifa, Saif. What about Aksa, Farhat, Hiba? Did you all not attempt the test? So last Friday, yesterday's marks you must have not received, no? Friday's test that have occurred. I think your syllabus was motion in 2D.
No.
That you have not received. All right. So this was marks. So these are the marks of last Friday. Fine then. So Alan and Saifullah score is good. Maimuna is also has scored well. Okay, Farad. And specifically, please tell me about physics part, because I haven't received this score. Otherwise, usually I receive all your grades. Please tell me specifically about physics, all of you. Okay, ma'am. So second one you have not attempted. First I have received, and this is I think the score you're telling me for the third one. All right. So Hanifa 100, Alan 140, 107 Sir. All right. So these are good scores. 140 is an excellent score. Alan 100 and it's been all right. Just pay attention to whatever scores you're getting. No, these are just because of the correct answers. Number of correct answers should increase with the score. Others also answer. Alan has only answered. Alan, your answer is right. Others also, this is the easiest question to begin with. Basic pulley system. Saifullah is also correct. At least this question all of you should answer. These questions are the minimum which we study for 11th. Farhat, can you tell me the score of biology that you have scored? Just text me the score of bio which you have scored. And also Hanifa. Okay, Farhat. At least in biology, all of you try to hit 300, 290 to 300 minimum in your mock tests. Because however you score in physics and chemistry, until and unless your score is still 300 in your bio, 500 won't be crossed. This is 4 kgs, this is 6 kg. See, this is going up with acceleration. This is a very basic question. This is coming down with acceleration. A. Okay. What about you, Hiba and Aksa? So this is mass will be 4g, that is m into g. This is going to be 6g. Now accelerations directly use this formula, m2 minus m1 by m1 plus m2 into g. In one line, you will get your answer, that is 6 minus 4 by 6 plus 4 into g. So this is 2 by 10 into g, that is g by 5. So B option is right. Class, resolution of vectors, perform it here only. See, let's say the reaction, let me write this as R. Reaction is this. This angle is theta. These, I think all of you must be knowing this. If this is mg, this will also be theta. This should be at your fingertips, this much practice. And vertically opposite angles, this will also be theta. So this becomes our cos theta. Perpendicular will become our sine theta. And here you will be having the pseudo force. That is ma, mass of body into acceleration of the system. There is the formula. M is mass of body, acceleration is acceleration of the system. This is what you have to write. Now see, now this is easy for you to write. Just all the forces will balance each other. See, r sine theta will be equal to ma and r cos theta will be equal to mg. So r cos theta is equal to mg, and one more thing what you can do, directly you can take the ratios. Right, you can directly take the ratios. So if you take the ratio, this would be tan theta, right? RR gets cancelled, sine by tan, so cos is tan. MM also gets cancelled. This is A by G. So acceleration is G tan theta. This was only asked, no? So D option, D tan theta. See, in your exam, NEET exam, you'll have to perform these calculations. So try with very minimum space, very minimum space. So try to make all these within the question only, within the question itself. And again, I'm saying those who are not able to reach 300, please boost up your score. At least try to score more in biology, at least 300. Then only your physics and chemistry would help. Alan, how was your board exam? Physics board exam? Were you able to manage? All the questions went well? Alan, Jason?
Yes, ma'am.
All right. And what about you, Hanifa? Your board exam? Hanifa, Hiba, Memuna? Physics exam. How did it go? Okay, okay, ma'am. And Hiba and Hanifa, you also please let me know. How was your exam? Memuna, if you have the question paper with you, currently physics 1, please send me it on WhatsApp. I think you must be having my number already. So please send me it on WhatsApp after the class or whenever you have time. See, in this question, so most of you have answered it correctly only. What is the total mass? If you see the total mass of this system, what is the total mass of the system? We have 4 kgs, 2 kgs, 1 kg. That is 4 plus 2 plus 1, that is 7 kg, right? This is the total mass. And force is 14 Newton. Force that is applied is 14 Newton. So it's like this is force is applied, acceleration is there. So force is equal to ma, that is 14 is equal to 7a. Acceleration is 2 meter per second. Now you are just asked to calculate it between A and B. Between A and B means only 4 kg is involved. So if 4 kg is involved, F dash will be net force minus 4 into 2, that is mass into acceleration, that is 6 Newton. F dash. So this is the option. So till now, only Alan's answer is right. See, this is normal reaction. Total length is L. So lower half and upper half is mentioned. So it is saying lower half is rough. It means frictional for this part is rough. And this part is smooth. So let's say this is L by 2. This part is also L by 2. Now, Saif, check your answer using L by 2. I think now your answer will be different. Again, mg force will be acting downwards. Here, this will be theta. So this becomes mg cos theta. This is going to be mg sin theta. So block is stationary when your mg sin theta, right? Mg sin theta multiplied by L. This is how we write frictional force. We are going to write it mg sin theta L. Force, this is the force into the displacement. Now this is equal to the frictional, this is mg sin theta into L. And what is the frictional force that is acting? Cos theta. This is mg cos theta, but L by 2 this time. Right? Net work done by the block in going from top to bottom. When it is at the topmost position, entire length was L, mg sin theta was acting. So mg sin theta into L. This is how no, we write work done F dot D. Similarly, here also, this is also F dot D. When it is stationary, mg cos theta is balancing R. That's why this is stationary. Now you just have to take the ratio. Mu will also come. No, frictional forces here. Mu mg cos theta L by 2. Understood this part? R is equal to mg cos theta. How do we write frictional force? Mu n, mu r, and r is mg cos theta. So frictional force is mu mg cos theta. And now this time frictional force is balancing the distance when it is halfway. When it was here initially, then it was mg into mg sin theta into L directly. Now this is mu mg cos theta L by 2. You just have to calculate mu from here. See, mg will get cancelled. L will get cancelled. Mu will be 2 sin theta by cos theta. Mu is equal to 2 tan theta. So you can notice the calculations are not lengthy in laws of motion. It's just that FVD is a little difficult. Once you are through with this, calculation is easy. You just have to check which forces are balancing each other. So only Saifullah could answer this question. Saifullah, your answer is right. Others, pay attention to here. This is a very easy question. See, block is there. Let's say this is a block. This is the velocity. So this block B will come to rest if whatever is the force applied is vanished by the frictional force, right? If frictional force is equal to the force applied, then only this will be equal. Now, what is the frictional force? Again, the normal reaction will be balancing the gravitational force. Frictional force is mu n, and n is equal to mg. So frictional force will be mu mg. So frictional force is mu mg. Force applied. Now force applied, what is the formula of force? Force applied, this is F, which is equal to ma. Now, if force is equal to ma, m will get cancelled. Now see, mu mg, mu g, even if you write, or we'll add the n, cancel it. If you write this as mu mg, acceleration can be written as velocity by time. Now let's cancel this. So from here, after a time, only time is asked to us. So time will be equal to V by mu g. So this is option V by mu g, option A. Note it down, class, and text me done once completed in the chat column.